Okay, so this is a little practice on being able to identify hydrogen bonds. All right, so in each of these examples, I want you to take a look at the molecules or the parts of the molecules that are shown, and wherever there's a dotted line, we want to say yes, that would be a hydrogen bond, or no, that would not be a hydrogen bond. All right. So remember that for something to be a hydrogen bond, you have to be able to say yes to three different situations. All right. First of all, is there a lone pair on a nitrogen, oxygen, or fluorine? Which, if there's a nitrogen, oxygen, or fluorine, there should be a lone pair on it. All right. And is that atom near a hydrogen which is covalently bound to a nitrogen, oxygen, or fluorine? Okay. So let's take a look at the first example here. All right, so this right here is shows a lone pair on a nitrogen, so that would satisfy this part right here. All right, so we could check that box. All right, so far we could have a hydrogen bond, but the other thing that we need is to have it needs to be near a hydrogen which is covalently bound to a nitrogen, oxygen, or fluorine. Well, we've got a hydrogen over here that it's close to, but it's bound to a sulfur. All right, so it's not one of those three elements that is needed for the hydrogen bonding. So in this case, we can't check. We can't check those. We can't check those boxes. So therefore, since we can't check all three of those, the answer would be no. All right. Remember, an analogy to this is to think about what allows magnets to stick. We need the north end of one magnet to be near the south end of another magnet. And if you can't check all of those boxes, the magnets aren't going to stick to each other. All right. So, so in this case right here, this right here would qualify as a NOF. So we can check that box right there. Is it near a hydrogen connected to a nitrogen, oxygen, fluorine? And the answer to both of those would be yes. All right. So all three of those conditions could be checked, and therefore, yes, that would be a hydrogen bond. All right. Remember, if we took this molecule right here and we separated, if we put it way over here, that distance would not be close enough to allow for that attraction to occur. They have to be relatively close in space for that to occur. So what about this example right here? Well, this is an interesting example because we have what will qualify as a NOF right here. So I could check that box right here. And you might think, well, don't we have a hydrogen connected to a NOF right here? Well, we could say, yeah, we've got that right there. So do we have a hydrogen bond? The answer to this one is no, because this NOF right here is not close to this hydrogen right here. All right. The odd thing about this is these actually could hydrogen bond. It's just that this whole molecule right here would have to move upwards to put this lone pair in proximity to this hydrogen. All right. So this is an example where it wouldn't hydrogen bond because it's not close enough. All right. But these two molecules would hydrogen bond in reality because all you have to do is move this molecule so that it's oriented the right way. An analogy is if you put two magnets together. If you put two magnets together so that their south end, both of their south ends are near each other, they're going to push apart. It's not that the magnets don't stick to each other, it's that they don't stick to each other if you hold them that way. And what would naturally happen if you held the opposite ends, those ends towards each other, and you let go? Immediately one of the magnets would turn around so that the side of it that does stick would stick to the south end. In this case right here, this side right here, that is a hydrogen covalently bound to a NOF, so I could click yes to that. And is it near something? Yes. And is the thing that it's near either a nitrogen, oxygen, or fluorine? Yes. So this would qualify as the NOF part of that. So in this case, yes, that would be a hydrogen bond. All right. In this case right here, we have two water molecules. And you might remember we said that water molecules do hydrogen bond to each other. The question is this the arrangement or the orientation that the molecules would have relative to each other to create that hydrogen bond? All right. So this right here is a hydrogen connected to nitrogen, oxygen, or fluorine. We can say yes to that. Is it near another molecule? Yes, we can say to that. And the thing is, what is the thing on this molecule that it is near? It's near another hydrogen connected to the oxygen. All right. We need this thing right here to be near a NOF. All right. So essentially, all you need for this thing to hydrogen bond is for this molecule right here to basically rotate counterclockwise so that that oxygen would be right here. In this particular position, that would actually be, not only is it not a hydrogen bond, but it's actually a repulsive relationship. Okay, so that would not be a hydrogen bond. Let me go back to this example right here. We said that this is not a hydrogen bond. And again, not only is this not attractive, but it's actually a repulsive interaction in the way that it's drawn. All right, that's because this would be a delta negative because of this bond right here. This right here would be delta negative because of this bond right here. And if you get two delta negatives together, they want to push apart. All right. So what about this last example right here? This right here would qualify as an H connected to a oxygen. So that would be an HNOF. Is it near something else? We could, yeah, that's near another molecule. And does this right here then qualify as this last thing that we need? Is that a nitrogen, oxygen, or fluorine? Nope, that's a sulfur. So we can't check that. So these guys would just not really, they wouldn't push apart, they wouldn't attract, but it's definitely not a hydrogen bond. All right, so I hope those examples give you a better idea about what a hydrogen bond is.